This is called the ground state electron configuration. And this is called the excited state. That means we are giving the required amount of energy to jump that electron from 2s level to the 2p empty level, or 2p orbital, which is empty already. Then this is the electron configuration of this, and carbon has only two unpaired electrons in its ground state. See, according to the ground state configuration, you can see only two unpaired electrons. If you have already followed the second lesson, then you know that the number of the bonds can be formed only by the unpaired electrons. If it is not unpaired, anyhow it make it unpaired and then form bonds. So according to the ground state electron configuration of this carbon, it can form only two bonds. But according to the electron configuration, in this, we call that the excited state, we have four bonds. But these two are in two different energy states. You know that if you get that the 1s energy level, then if you get that 2s energy level and 2p energy level, see, there is an energy gap like this. This may be the gap. Very small gap, but there is a gap. Then, if this carbon forms bonds with that by using this 2s electron and 2p electrons, then those bonds will be in different energy states. Why? Like this. Well, we have 2s here, and I write it like this 2p. Then we have unpaired electrons. Or if you excite it, then you have four unpaired electrons. Then if something forms a bond with this, and another three bonds with these, say giving one electron from another element, it can form like this. Then this bond may be in low energy state, and these three bonds may be in higher energy states. But if you get that CH4 Puta, remember that normally carbon forms four bonds. Always carbon forms four bonds. Then one of the CH bond will be in low energy state. That means say the bond energy is 100 joules, but the other bonds may be 110 joules. But practically, if you measure the bond enthalpy, so the bond energy means energy required to break this bond. Bond energy normally refers the energy required to break bonds. So one bond can be broken giving 100 joules, but other bonds needs say 110 joules because it is in a bit higher energy states. Then, but practically all the bonds are in equal energies. How it happens? Then at that time only we need to know about the hybridization. Then we need the hybridization. How that hybridization occurs, I am going to go in detail about the hybridization later. But now we need to know the electron configuration of carbon is 1s2, 2s2, and 2p2. And it has only two unpaired electrons, so it can form only two bonds. But practically, carbon forms four bonds. How it can form that four bonds? See, contribute for the formation of large number of carbon. Then it is the ground state. What is the ground state? This configuration is known as the ground state configuration. But this carbon can form four bonds. How it can happen? Because of the hybridization. That process is known as the hybridization. Then some features of the carbon that contribute to the formation of large number of bonds. I told you that the carbon can form, or nearly we have 2.5 millions of organic compounds, nearly, right? It may be vary, but as a rough value, say it is 2.5 million. Then why that carbon can form that much of bonds? What is the important feature of carbon process to form that many number of compounds? If something forms more compounds, means the bonds are stable and the compound must be stable, otherwise it will not form. That means the compound formed by carbon may be very stable, that's why it forms. Some features of the carbon that contribute to the formation of large number of organic compounds are given below. Why? Between two carbon atoms, it can form single bond, double bond, or sometimes triple bonds. In between any two atoms, the maximum number of bonds you can find is triple bond, not more than triple bond. If I get this carbon, see, carbon can form carbon-carbon single bond. Carbon can form carbon-carbon double bond. And carbon can form carbon-carbon triple bond. But carbon will never form carbon-carbon four bonds in between two carbon atoms. So any two atoms will never form more than three bonds in between those atoms. But carbon can form four bonds with different elements. It may be like this. More than two elements will involve with that if it forms more than three bonds. But in between two carbon atoms, the maximum number of bonds may be three. These are called the multiple bonds. This is called single bond, this is called double bond, and this is called triple bond. All these bonds are very stable. That's why carbon can form them. If carbon can't form them, that means they may not be stable, or sometimes we call that unstable. Because of the stability, carbon can form single, double, low, triple bonds. If you get that, this is called ethane. Or I will draw this one. This is a hydrocarbon. Hydrocarbon means the compound contains only the carbon and hydrogen. This is the main ingredient of the gas cylinder in our domestic gas cylinders. This is the main ingredient that is called propane. Propane and butane are the main ingredient of that. Among that, the major percentage, the majority will be, or maybe, the propane. This in propane, you can see that there are some carbon-carbon single bond. And also it contains carbon-hydrogen single bond. All these bonds are stable, that's why they form. And if you get that ethylene, ethylene may be like this. There is a double bond between carbon atoms. This is called ethylene. In this ethylene, we have a double bond. Later we are going to, if you have already done that, the hybridization, you have an idea about these single bond, double bond, and triple bond. How they form, what are the atomic orbitals or hybrid orbitals involved in the formation of such bonds. Then this is called propane. In propane, you have single bonds. And there is a double bond. In ethylene, ethylene is the thing we use to produce the shopping bag, polyethylene. We can polymerize these ethylene molecules by using high pressure and heat, this ethylene molecule is known as the monomer of that polymer, polyethylene. Monomer, polyethylene. Monomer of polyethylene is the ethylene molecule. Right? And this is the triple bond. The triple bond is found in this compound. That is, I am talking about the known compounds to you. This is called the ethine. Or if you add water to this calcium carbide, you will get this ethine, HC. Oxygen and ethine can be mixed to get heat. In ventilating industry, we use this. This is called ethine. Ethine can be obtained from this carbide. Right? This contains a triple bond. In addition to this carbon single, double, or triple bonds, in organic compounds, we find carbon and hydrogen bonds. And it has a higher bond enthalpy. Higher the bond enthalpy, higher the stability. Means we need to give high amount of energy to break this bond. So it is stable. And it possesses a higher bond energy. The relevant information is given in the following table. That means the bond enthalpies are given in kilojoules per mole units. Carbon-carbon single bond, nearly it is 346. Carbon-carbon double bond, it is 610 kilojoules per mole. That means if you need to break carbon-carbon double bond, 1 mole of carbon-carbon double bonds, then you need to give this much of energy. The triple bond required this much of energy, 835. Carbon hydrogen single bond is 415. But silicon bond, you can see that it is 226 compared to the 346. Nearly the difference between this carbon-carbon single bond and silicon single bond is nearly 120 kilojoules. That's a very big amount. So carbon-carbon bond is much stable than the carbon-silicon single bond. Carbon-carbon single bond is much stable than the silicon single bond. That's why, though this carbon and silicon are found in the same group in the periodic table, that is group number 14, it is strong. You can see that the carbon-carbon single bond is strong than the silicon single bond. The reason may be the silicon is bigger than the carbon. So when the bond distance increase, the bond become weak. And the silicon hydrogen bond enthalpy is 318 compared to the 415. Then the bonds formed by carbon compared to the silicon or other elements are strong and stable. That's why this carbon forms more compounds. And the other thing is, in addition to this carbon and hydrogen, organic compounds may have nitrogen, oxygen, chlorine, bromine, iodine, sulfur, phosphorus, and some more elements. That means carbon can combine with many other elements than the other elements. A carbon atom can form 4 covalent bonds. 4 stable covalent bonds can be formed by carbon, but some other compound elements, they can't form much bonds. Then hence, it is seen that the large number of other atoms or groups can get attracted to the carbon atom in chain or in ring shapes. Chain means puta, like this. See, if carbon atoms combine like this, those are called acyclic compounds or chain compounds. is just like a chain. But there are some other compounds like this. We have carbon and they connect like this in ring shape, circular way. These are called the um, cyclic compounds. These are called the cyclic compounds. So this is called the cyclic propane. Why? We have three carbon. Depending on the number of carbon, we name them. Later we are going to study. I think you have this table here. According to this table, we give the names to the organic compounds. If you have only one carbon in that compound, then the name is known as methane, like that. If you have two carbon, then it is ethane. If you have three, that is propane in this case. Here you have three carbon atoms, then it is called, this contains three carbon atoms and it is cyclic, therefore it is called cyclic propane. This is not a cyclic, but it contains three carbons, so it is called uh, acyclic compound or just propane. Three carbon means prop, so it is propane. So why that carbon forms many compounds? Because of that carbon can form carbon-carbon single, carbon-carbon double, low carbon-carbon triple bonds, and the bonding enthalpies are considerably high. In addition to that carbon-carbon bond, carbon can form carbon-hydrogen, carbon-oxygen, carbon-nitrogen, carbon-sulfur, and with many other elements. So the carbon can form stable compound, the bonds, so it is very stable. And also, if a compound is stable, that compound must be stable in two ways. One is called the thermodynamically, that compound must be stable, and the other thing is called that kinetically, it must be stable. And kinetically and also thermodynamically. Although the reactions of organic compounds with oxygen, we call that the combustion are exothermic. These compounds are stable in room temperature due to the stability in those compounds are kinetically stable. What does it mean? Kinetically and thermodynamically. Thermodynamics means thermo means for the heat, right? If something is stable, it is stable because it has a less amount of energy. If something has a higher amount of energy, it may not be stable. If something has a very high energy, then it may not be stable. Why these elements tends to form compounds? Because it needs to decrease the energy. Energy can be decreased only by combining with the other elements or with the same kind of elements. So bonds are formed in order to decrease the energy. Then carbon forms this carbon-carbon or carbon-hydrogen bonds in order to decrease the energy. But still, if you combine these organic compounds with oxygen, it gives huge amount of heat, turning that into CO2 and water. If it liberates huge amount of heat means it must contain that heat. If doesn't have heat involved with that, then it cannot release it during the reaction. If something release energy means it is not thermodynamically stable. If something is thermodynamically stable, then it releases lesser amount of energy during some reactions with other elements or even in the combustion. So this carbon organic compounds normally liberate huge amount of energy. That's why we use that in the gas cylinder. it contains propane and butane. Then when we burn them, it gives us energy. Means the organic compounds, they are not stable thermodynamically, but they are kinetically very stable. That means to burn this, we have to give some amount of energy. Without giving energy, those compounds may not ignite. You know that we have the paper. Paper consists of carbon, hydrogen, and other elements. Those are organic compounds. And we have plenty of oxygen in our atmosphere. But paper may not catch fire automatically. We have to heat them up to certain temperature to catch fire. Means those compounds are kinetically stable. If something is stably either thermodynamically or kinetically, those compounds can be considered as stable. These are very basic things you need to know before we go into the theory part. Right? Then these are the cyclic compounds. We have some different notations to express them. So the cyclic compounds, normally you can use these kind of structures to draw them, and we will study them later. That my screen is flickering. That means the letters are vibrating. Have you experienced the same, Pudha? ඔයාලට මේ ස්ක්‍රීන් එක පැහැදිලිව පේනවද නැත්නම් නිකන් බොඳ වෙලා වගේද පේන්නේ? It is flickering. Flickering means vibrating the letters and others. Okay, can see. Good. Then hydrocarbon. Hydrocarbon are something like this. See, the hydrocarbon is an organic compound consists entirely of hydrogen and carbon. Like methane, you know that methane. Methane is CH4. And propane is, normally we write that propane, CH3, CH2, and CH3. Why? We have carbon-carbon bonds and carbon-hydrogen bonds like this. This has 3 carbon hydrogen. Then we write this as CH3. And this carbon has only 2 hydrogen atoms attached. So we say it is CH2. And this is called again CH3Y. That carbon has 3 hydrogen atoms. This is called the condensed form of the formula. Condensed form of this formula. Then this is propane. Propane can be written as CH3, CH2, and CH3 like this. And this is called the methane or methane. Methane is CH4. Or we call that the biogas. Biogas can be this one. Then these kind of compounds are known as hydrocarbons. A hydrocarbon is an organic compound consisting entirely of hydrogen and carbon. Hydrocarbon form which one the hydrogen atoms has been removed are functional groups are called that the alkyl groups. That means, Putta, if you have that CH4, CH4 can be written as this. That is CH4. We write it in the condensed way, CH4. But if you remove one hydrogen atom from this, say now you have this CH3 and another vacant orbital which can contribute for or which can combine with something else. So this is known as the alkyl group. That means if you remove one hydrogen atom from hydrocarbon, the remaining part is known as alkyl group. Or sometimes we call that hydrocarbyls. Hydrocarbon is an organic compound consisting entirely of hydrogen and carbon. And the hydrocarbon from which one hydrogen atom has been removed are called the alkyl groups. Basically, if you remove hydrogen atom from hydrocarbon, the remaining part is known as alkyl group. And it is denoted by R. R may be any alkyl group. It may be CH3, it may be CH3, CH2. Why? It is CH3, CH3 like this. Normally, carbon forms 4 bonds. If carbon does not complete its 4 bonds, then you can complete that by putting extra hydrogen to that. Then if you remove this hydrogen atom, then this part also known as alkyl group and it is written as CH3CH2. And if you have any number of carbon atoms in the compound, you can remove any of the hydrocarbon atom, but basically we remove from the terminal atom. No matter from where you are removing that remaining part is known as alkyl group. Then if you get the hydrocarbon as CH4, the alkyl group is CH3. If you get this CH3 as the hydrocarbon, then the alkyl group will be CH3CH2 only. Then hydrocarbon can be separated into 3 main groups. Those are saturated hydrocarbon, unsaturated hydrocarbons, and aromatic hydrocarbons. What does it mean by the saturated hydrocarbon? Saturated hydrocarbons are the something like this. Before that, I'm asking a question from you. Do you know something like this? Say you have a cup of water. Say you have tea. Then you can add sugar to that. Say you have teaspoon like this. Then you will add 1 teaspoon of sugar and dissolve it. Then everything will be dissolved. After that, you are adding another teaspoon of sugar and again stir in that until everything dissolves. It may be dissolved. And you add in another teaspoon of sugar, then again stir in you, then it may be dissolved entirely. And then you can see that within your cup, you have water or tea and no sugar grains. That means it is completely dissolved. And again, you are adding another teaspoon of sugar and stir. At that time, you will see that no matter how much you are stirring it, still some amount of undissolved sugar may be remaining in that. That means you have dissolved the maximum amount of sugar in that water. Maximum amount of sugar has been dissolved in that water. That means no more sugar can be dissolved in that. At such an instance, we call this is saturated with. This is saturated with sugar. That means you have added the maximum amount of sugar. No more can be added. In the same way, the saturated hydrocarbons means, say we know that the carbon can form maximum of 4 bonds. This carbon can form maximum of 4 bonds, no more hydrogen can be added to this. That means, say if you get that the CH4, this consists of the maximum number of hydrogen atoms and no more hydrogen can be added to this. So we call this organic compound saturated with hydrogen. This organic compound saturated with hydrogen. So such compounds are known as saturated hydrocarbon. That means no more hydrogen can be added. The saturated hydrocarbons are the hydrocarbons that contains only single bond between the carbon atoms. No double or triple bond between carbon atoms. No double or triple bond can be found between the carbon atoms. Then we call it is saturated with hydrogen. Then the such compounds are known as saturated hydrocarbons. The saturated hydrocarbons are the hydrocarbons that contain only single bond between the carbon atoms. If you have more carbon atoms than one, that means 2 or more, then only a single bond will be found among the carbon atoms. That means no double or triple bonds. Saturated hydrocarbon molecules can be cyclic or acyclic. Cyclic means the compounds having cyclic shapes like this. See, these are called cyclic compounds. They complete a cycle. Acyclic hydrocarbon is one in which a chain of carbon atoms has four or has formed a ring. Cyclic none, it forms a ring, otherwise it will not form a ring. A cyclic hydrocarbon is one in which a chain or a carbon atom has formed a ring. An acyclic hydrocarbon is one that does not contain a ring of carbon atom. Ring of carbon atoms, right? So if you get that the CH4 like this, carbon, hydrogen like this is anyway acyclic. And if you get this carbon organic compound, this is called the ethane. Later we will study how to write down the names. And another one having 3 carbon. This is called acyclic propane. It is not a cyclic one, it's straight chain. But this is called this one. Say you have carbon, carbon, carbon bonded with single bonds and having 2 hydrogen atoms on each carbon. Then it is called cyclic propane. Why? It form a cycle, circle or ring. Then we call cyclic. This is cyclic. These are acyclic. Acyclic compounds, and this is acyclic compound. Next one, unsaturated hydrocarbons. That means those compounds are not saturated with hydrogen. That means you can add more hydrogen atoms to those compounds. See, unsaturated hydrocarbons are the hydrocarbons that contain double bond. Normally we call that in alkene, and triple bonds. Those compounds are called alkyne between carbon atoms. See, if you have a compound like this having a double bond, this is called alkene. any hydrocarbon having double bonds between carbon atoms are known as alkene. Then this is an alkene. Alkene, A-L-K-E-N-E, alkene. This is ethene, E-T-H-E-N-E, ethene. And alkyne, K-Y-N-E, alkyne. Alkyne normally have triple bond between carbon atoms. At least one triple bond must be there to be an alkyne. This is called ethyne. Now you can see that Putha, alkene, the name ends with "ene". Alkyne, the name ends with "yne". We call that "ine". But as we have two carbon atoms, this is eth, this also eth, ETH and ETH. Having two carbon, eth. This is an alkene, so the name ends with "ene". Alkene, ethene. This is alkyne, the name ends with "yne". Ine, that is ethyne. Ethene, ethyne. Then aromatic hydrocarbons. This is a different class of organic compound. We have a separate lesson to cover the chemistry of these aromatic compounds, basic compounds. The smallest aromatic compound is known as the simplest aromatic compound is the benzene. See, the aromatic hydrocarbons are the hydrocarbons that contain benzene ring or similar features. The very, or we call that the simplest aromatic compound is benzene, and benzene written as this. Later we study why this benzene has this structure. By now you need to know, you have to draw a hexagon and draw a cycle in that or inside that. Those are called the aromatic hydrocarbons. Is it clear, Buddha? Can you understand all these things? Pahanma, can you understand these things? I am teaching to you, right? So if you can't understand, if you need some more clarification, please raise your hand or just send me a text. Then I will explain them again. This is something new to you. So at the beginning, you will feel that that is not suit to you, but you will see that this is really interesting. This is very easy. All the students, they are going to get this organic chemistry question in exam. The other one, I can't see properly the things because my screen is flickering. No, I can't see the name. Pahanma, okay, understood. Oh, right. Then the type of hydrocarbon, types of hydrocarbon. We call the aliphatic hydrocarbon, aromatic hydrocarbon. Basically, we have aliphatic and aromatic. Aromatic means the compounds having these kinds of rings. You may have already seen many compounds. Even if you go through your past papers, I will show you past paper, then you can see that those questions consist of rings like that. I had here the question papers, past papers. The other thing is, you know that all these things than me by now. See the MCQ paper. All right. I need that past papers. I'll get the very recent paper, maybe the 2022 essay paper. This one. In this paper, you can see that question number 5, question number 6, and question number 7, and then the question number 8. This is organic chemistry question. In this question, at least you have this ring, right? May make a thamai the benzene ring. We have different structures for benzene. This is one way of writing the benzene. This is one way of writing the benzene ring. And if you go through that the MCQ paper, you can see there are plenty of benzene rings. See, this is the benzene ring. Another way of this is called the Kekulé structure of the benzene ring. Like this. And see how many MCQs are available in this paper. We can count and understand. See, this also organic chemistry question. I hope that you may have seen these are organic chemistry questions. Here, there's a double bond. That means unsaturated. Alkene. This is an alkene. See how to name this compound. The question says, which of the following gives 3-bromo-3-methyl hexene as the major product when reacted with HBr? There are some reactions relevant to the organic compounds. This is the reaction between alkene and HBr. They are asking about the product. Once you do this product, you can easily answer about this question. These are pretty easy. Right? See, these are organic compounds having benzene ring. Benzene ring. Another way of writing that benzene ring is like this. Alternative double bonds in that ring. Actual structure of benzene, if you need to draw the structure of benzene using carbon and hydrogen, you will see that this is a hexagon. In that hexagon, each corner, we have a carbon atom like this. Then you can connect them using this kind of single bond and then alternative double bonds like this. And each carbon may have one hydrogen atom on it. Each carbon has a hydrogen atom like this. This is the structure, but normally we don't put all these hydrogen atoms. Then it is written like this, or sometimes we put this circle inside that. If you carefully examine this one, Putha, here, see, we have carbon atom and two hydrogen, carbon atom and two hydrogen, carbon atom and two hydrogen. Without drawing the carbon and hydrogen, we can just connect the carbon atoms using single line, these lines. If you have a double bond, then you can draw another line like this. If you have another one, you can draw like this. Or you can draw like this. That means these two carbon contains a double bond like this. This is called cyclohexane. This is called cyclohexane. Not the benzene, right? So see, in benzene, you have only one carbon on each car, or one hydrogen on each carbon. But in this case, you can see that there are two hydrogen atoms on each. Then here, in real benzene, you have only one hydrogen atom on each carbon. Then types of hydrocarbon. Aliphatic hydrocarbon. Aliphatic hydrocarbons are the organic compounds having only carbon and hydrogen and no ring. They have only the straight chains. See, alkane, hydrocarbon which has no double or triple bonds between carbon atoms are known as alkane. Hydrocarbon which has no double or triple bond between carbon atoms. This is the simplest organic compound. We call that the methane or methane. This is the next organic compound having carbon and hydrogen. This is hydrocarbon. Then in this case, you can see that it has no double or triple bond. Then there can be millions of carbon atoms in a given chain, in a given compound. You know that DNA, RNA, they have some special structures having millions of atoms in one molecule. Such a complex. The next one is alkene. Alkene means having at least one double bond within the carbon chain. See, the alkene hydrocarbon which has one or more double bond between carbon atoms as main functional group. Give me a second. Yes. The next one is called the alkyne. See, in alkene, we have double or triple bond, double bonds, at least one double bond. See, this is the simplest alkene. We call that the ethene. Ethene has only one double bond between carbon atoms and it has only two carbons. So it cannot have more double bonds between carbon atoms. And alkyne, the simplest alkyne is the ethyne. So ethyne is this. It has a triple bond. So the alkyne, the hydrocarbon which has one or more triple bond between carbon atoms as the main functional group. Actually, these are not the functional groups, right? Though it mentioned as the functional group, these are called the active sites. Those places may show some reactions, but not functional group. So having double bond, alkene, having triple bond, alkyne. Then aromatic hydrocarbons. Aromatic hydrocarbons are the hydrocarbons having benzene ring. See, aromatic hydrocarbons which contains one or more benzene ring are known as these aromatic hydrocarbons, or sometimes we call aryl hydrocarbons. Aromatic hydrocarbons, so arene, or sometimes the aryl hydrocarbons are called that aromatic. There are some rules to follow to be a compound aromatic. We will study that under benzene. There is a separate lesson called the benzene. Under that, we are going to study about that. Then alkane. We need to know what really alkane are. In organic chemistry, an alkane, or sometimes we call that paraffin, is a saturated hydrocarbon. In organic chemistry, alkanes are the saturated hydrocarbons. Alkane consists only of the hydrogen and carbon atoms. All bonds are single bonds. That means in between carbon, all the bonds are single bonds. As I explained earlier, if you have, say, you may have C5H12, that is a hydrocarbon. We write it like this: 1, 2, 3, 4, 5 carbon, and each carbon will have CH bonds to complete the 4 bonds. Say hydrogen, 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 and hydrogen, like this. So these are called the hydrocarbon, or sometimes we call that the paraffin. The organic compounds, an alkane or paraffin is a saturated hydrocarbon. Alkane consists only of the hydrogen and carbon atoms. All bonds are single bonds. They have the general chemical formula CnH2n plus 2. CnH2n plus 2. That's how I straight away could write this. Maybe Cn, if n is 5, 2n is 10. 10 plus 2. Cn H2n plus 2 is the general formula of this hydrocarbon. Alkane can be written as CnH2n plus 2. An alkane belongs to the homologous series of the organic compounds in which the member differ by the CH2 group. Means, say you have hydrocarbons CH4, C2H6. This is 2 into 2 plus 2, 6. And C3H8, 3 into 2, 6, 6 plus 2, 8. And C4H10 like that. CH4, C2H6, C3H8, and C4H10. The difference between this one is CH2. Difference between this one is CH2. The difference between this one is also CH2. Then the preceding members differ only by that CH2 group. There are two main commercial sources of hydrocarbon or the alkane. Those are crude oil and natural gas. You know what crude oil and natural gases are. So that will be. Then name of an alkane ends with the suffix "ane". This is called methane. The name of CH4 is methane. The name of C2H6 is called ethane. And C3H8 is propane. C4H10 is called butane. Butane is written as butane, B-U-T, but, not the B-U-T-E. This is called butane. Then alkyl groups. Alkyl groups are the remaining part after removing or by removing one hydrogen atom from this alkane. Alkane CH4, C2H6, C2H8, and C4H10. If you remove one hydrogen atom from each, then the remaining part is known as alkyl group. See, a group formed by removing a hydrogen atom from corresponding alkane is known as alkyl group. It is commonly abbreviated with that R. Earlier I explained about this one. Say you have these hydrocarbons. First one is methane, ethane, propane, and butane. Then you can remove one hydrogen atom from each. Then it becomes CH3, C2H5, C3H7, and C4H9. Then these are the corresponding alkyl groups to the alkane. CH4, you remove hydrogen atom, you get that CH3. Then the name of this alkyl group ends with YL, suffix YL. See, a group formed by removing a hydrogen atom from corresponding alkane is known as alkyl group. It is commonly abbreviated with this R when drawing the chemical structures. ඒ කියන්නේ පුතා ඔයාට හම්බුනොත් RH කියලා එකක්. That means alkane. That R may be CH3 and you are adding one more hydrogen to that, it becomes CH4. If the R group is this one, so RH will be the C2H5 and another hydrogen. That means C2H6. This one. Ethane. This is ethyl. Why? The name ends with YL. Prefix YL. Suffix YL. Suffix YL. That means it is adding at the end of the name. Then the name of these alkyl groups can be written. If it is CH3, that is methane. What you do is, we get that meth. Why? N is used to indicate this is an alkane. Then you remove that N part and add YL to indicate it is an alkyl group. So the name will be meth YL, that is called methyl. Then the name of this 2-carbon alkyl group is ethane. Then you remove N and this will be ETHYL, that is called ethyl. And then here C3H8, that is propane. You remove that N. Why? That N is used to indicate that is an alkane, but this is not alkane. This is an alkyl group. So you remove the N part and add YL, then it will be PROPYL. That is called propyl. Then butane, you remove N, so it will be butyl. It will be butyl. Methyl, ethyl, propyl, and butyl. Ethane, methane, propane, butane become ethyl, methyl, propyl, butane. Very simple how to get the name. Remove the N part, add YLO, IL part. So you will get the name of the alkyl group. Then just straight chain alkyl groups are generally by removing the hydrogen from the end carbon. Normally, I told you that earlier. Normally, we remove the hydrogen from the end carbon or the terminal carbon. Then you will get that the alkyl group. Then the branch alkyl groups are generated by removing the hydrogen atoms from an internal carbon. It can be like this. If you have 3 carbon compound like this, having hydrogen on each carbon like this, then you can remove this hydrogen, then you will get unbranched alkyl group, And if you remove this one, we call the branch. Why? We have some branches attached to that. So this is also a hydrocarbon. You can denote that by just capital R. Okay. For example, you can write down CH4, methane, CH3, methyl, then C2H6, ethane, ethyl, C2H6, ethyl. This is C3H8, propane, propyl. Like that. Then you may write down those. This is the alkane, and these are the alkyl group. So are these in your understandable level? I can't see the names, unfortunately, because of this flickering. Seharsa or someone is there. Yasindu, I think. Yasindu and Yasiru, maybe. Okay, done. Then we need to know the homologous series in organic chemistry. This one is known as the homologous series. What really that homologous series means? But under the root names used for the compound according to the number of carbon atoms and the name of the corresponding hydrocarbon are given in the homologous series. I use these names. I use this meth, eth, prop, and but. See, meth, eth, prop, and but in naming of these compounds. Those names I took depending on the number of carbon present in those compounds. So the homologous series is something like this. Root name. Root name is for one carbon is called meth. You need to know these things, right? Meth means that organic compound consists of one carbon atom. If it is two, then it is eth. If you add in, that is methane. Methane means alkane. If you have eth, then you can add ene. Then it is ethene. Ethene means alkene having two carbon atoms. If you have only one carbon in that compound, it is meth. 2, eth, 3, prop. P-R-O-P, prop. 4, but. But is written like but, not B-U-T-E. It is just B-U-T, but. That is called but. Having 5 carbon, pent. 6 carbon, hex. 7 carbon, hep. 8 carbon, oct. 9 carbon, non. And 10 carbon, dec. 10 carbon, dec. DEC. You better to use only the simple letters when you write down the names. These are called the root names. Root names are given according to the number of carbon atoms available in that particular compound. Next one is the formula of the alkane. Alkane. The general formula of an alkane is CnH2n plus 2. If you have, this is the n. If n is 1, then 1 into 2, 2, 2 plus 2, 4. That means it is CH4. It means having 2 carbon, then 2 H කියන්නේ 2 into 2, 4, 4 plus 2, 6. Then C2H6. C2H6 is the second hydrocarbon. The formula of the hydrocarbon having 2 carbon. Then you may fill up to 10 carbon. Fill it quickly. Having 3 carbon, prop. Then it is C3H8. Why? 3 into 2, 6. 6 plus 2, 8. Having 4 carbon, C4H10. Then 5, C5H12, C6H14, and so on. Write down up to 10. Then 7, C7H16. 8, C8H18. C9H20. C10H22. The name of the alkane, name of the corresponding alkane. By considering these alkanes are straight chain, that means no branches. Later you will understand what really it is, having no branches. Alkane, name of an alkane ends with suffix "ane." We add that "ane" to the root name. We add "ane" to the root name to obtain the name of the alkane. So here you have the root name meth having only 1 carbon. Say, then we call that methane, methane. You add "ane" as the suffix. So the meth, ANE, methane. It's a single name. Remember that, Puta. No matter how long your name is, you write down name as a single word. මේ බලන්න මෙහෙම එකක් තියෙනවා නම් මොනවාද? Propyl, say one propyl වෙන්න බෑ. අපි හිතමු 4 propyl, 4 propyl, 2 bromo, 5 oxo, like that. See, no gaps between. We don't leave space in between any name. You can put this hyphen to separate number and name, and you have to continue as a single word. You will practice how to read them. Then having 2 carbon in that particular hydrocarbon, the name ethane, propane, butane, butane, pentane, and complete the rest. Okay, let's see. Having six carbon, then hexane, seven carbon heptane, heptane, octane, nonane, decane. Then alkyl group. Alkyl group is obtained by removing one carbon from the corresponding alkane. Then the alkyl group will be CH3, C2H5, C3H7, C4H9, and so on. You may complete the rest. And the name of this alkyl group is obtained by adding il to the root name. Il to the root name. Where is that il? See, suffix il is added to the root name. What is root name? Root name is the name we obtain corresponds to the number of carbon. If it is one carbon, meth, two carbon, it, three carbon, prop, four bute, and so on. Then the name of the alkyl group will be met plus il, methyl. Methyl. Then ethyl, propyl, butyl, and so on. Complete the rest. right? Then C5H11, C6H13, C7H15, C8H17, C9H19, and C10H21. But according to your syllabus, Puta, it says that you will not be given the compound having more than 6 carbon in the parent chain. There may be more carbon in the entire compound, but maximum of 6 carbon in the parent chain. That means you need to know how to write down the names up to the 6 carbon. Means hex. But if you go through carefully in the past papers, you will see that there were some questions having more than 6 carbon in previous papers, right? But not in the recent papers. Then the name pentyl, hexyl, heptyl, octyl, nonyl, and decyl. Like that. This is called the homologous series. Mainly what you need to know, the root name, depending on the number of carbon, how to get the root name. 1 carbon it, 2 carbon it, 3 prop, 4 but, 5 pent, 6 hex, 7 hep, 8 oct, 9 non, and 10 dec. Then how you can get the name of the compound? By adding the suffix to the root name, also given just by considering the alkane corresponds to the carbon atoms. 1 carbon, 2 carbon, 3 carbon, then ethane, methane, propane, butane, and so on. And the alkyl group, because when we write down the name of the organic compounds, we have to consider, or we have many alkyl groups in those compounds, and you need to know how to get the name of that. So the name will be taken just by adding YL suffix to the root name. Root name taken from the number of carbon. If you have only 1 carbon, then the root name is meth, and you are adding il, suffix il to that to get the name. Okay, I hope that it is okay up to that. I hope that the other thing is you can understand Sinhala well. No, all I think Sinhala. According to name, Pahanma, Sasruta, I don't know whether a girl or a boy, Yasindu, Yasiru, Lakmi, maybe boys. Okay. Anything you need further clarification up to this, Buddha? No. Some says no. Okay. Then, features of this homologous series. මෙන්න මේකේ what දකින්න හම්බෙන special features. One, the difference between two adjacent alkane in homologous series is CH2. And I explained that earlier here. Vivalan. If you move from 1 carbon to 2 carbon, difference is CH2. 2 carbon to 3 carbon, difference is C. And 3 to 4, it is CH2. So the difference between two adjacent hydrocarbon, in the preceding hydrocarbons, it is equal to CH2. is equal to CH2, just CH2. And the second one can be prepared in same manner. Normally, Puta, remember that all the hydrocarbons are obtained from the crude oil and also from the natural gas. Natural gas is the gas deposits. The gas we obtain from the deposits. Deposits are available under Earth. Then the physical properties vary in a way. In a way means there is a proper pattern. Gradually increasing, gradually decreasing, or something like that. There's a proper pattern in the variation. And finally, the chemical properties are almost equal. At the time, the hydrocarbon may show very simple chemical properties. If you get that the homologous, that means the alkane, all the alkanes can be burned with oxygen. That may be the only chemical property. There are some other chemical properties like that. They can react with chlorine, bromine, and something like that. There are only a few number of reactions, known reactions in the alkane. Right? Basically, alkane can easily be burned. And the other thing you need to know is priority sequence in the functional group. Make a namputa, no need to understand right now. Automatically, you will understand that while we are doing that, because I am doing or I am teaching you in the increasing order of their reactivities. The priority sequence. Just according to the priority sequence I am teaching you, so you will automatically understand that. No need to worry about these things, though you can understand or not. Right? These things are maybe something like that. If you have something in a bag which is completely closed, if someone may say that it contains an apple. If you haven't seen that apple, later we are going to open and see that apple. In the same, very easy to understand these things, right? But you need to know the priority sequence. If you have NO2 and X means chlorine, bromine, iodine, right? X means the chlorine, bromine, iodine. Say you have chlorine or bromine or iodine in compounds. So those are labeled as X. That means if you have CH3Cl, that means this is a kind of functional group. If you have chlorine, bromine, iodine within an organic compound, maybe especially in hydrocarbon, then we don't consider that as a functional group. This is not a special functional group. And if you have NO2, say CH3NO2 is available, then again this is not a functional group. It's just a group attached to that organic compound. So we don't have special names for that, special compound containing them. But when we write down the name, we get it as nitro if it is NO2. Then you can see that you have only one carbon in this particular compound and it contains this nitro group. Then this is methane. You will see that this is how it become that methane. It is methyl because it contains only CH3 groups. Yes. But in naming system, Buddha, we have some rules in the naming. According to that, this is methane. You will study that, right? This contains this nitro group. Then this is called nitromethane. This is called nitromethane. Why? The substituent is nitro and the main chain contains only one carbon and it's a hydrocarbon having no double or triple bond. So it is called methane. So this is nitromethane. And this contains what are the chlorine and methane. Then it is called chloromethane. Why? When chlorine attached, that is called chloro, bromine, bromo, iodine, iodo. So halo compounds. Halide containing compounds are known as halo compounds. In the halo compounds, having one carbon, the halo compounds, if it contains chlorine, then it is chloro, bromine, bromo. Say you have CH2, CH3, CH2 and Br, then it is bromo having two carbon ethane. So bromoethane, bromoethane. That's how you get the name. These are called the substituent groups. Then this nitro is available as a substituent group, not as a functional group. Then RH. R means our alkyl group. Having H attached to that means alkane. If you have CH3R group and another hydrogen is attached, that means really it is CH4. CH4 is hydrocarbon. And it is an alkane. These are in the class of alkanes. That is an alkane. RH, alkane. And name as a functional group, we don't consider, or we don't have actually any of the functional group in alkane. But when we consider the hydrocarbon having double bond, those are considered or named as, again. Right. Then this one having two carbon or the double bonds, having double bond, we call the alkene. But in alkene Puta, this double bond is not considered as a functional group, but when we name them, we give a special name to that. So we can consider it as a functional group, but really it is not a functional group. Then ene is added. So if you have two carbon, then we are adding ene suffix to that. The name become having two carbon and hydrogen atoms attached there and having double bond. Eth and ene. Ene, why it is ene? Because it consists of double bond. Ethene. Eth plus ene, ethene. Ethene. Having triple bond ine, so it is ethine. If you have a triple bond between two carbon containing compounds, and it is called ethine. And NH2 group, again, may not be very special functional group, but you can get it as a function, then it is NH2, we call amine. The class of compound is called the amine, like this alkane, alkene, alkyne. Having NH2 group in organic compound, we call, say, CH3NH2, then this is the simplest amine we have. And we will study about the features of this amine. And having OH group, we call alcohol, methanol, ethanol, propanol, butanol, so on. Methanol, why? Having one carbon and OH group as the functional group, then it is called methanol, methanol. Methanol, methanol. Having two carbon, all ethanol. Having two carbon, it. එතකොට ඒකට නම ලියන ස්පෙෂල් system එකක් තියෙනවා. We get the name of the alkane, that is methane, and we are adding all to that, then it is methanol. Methanol. Then if you remove the last N, or last E from the ethane, and you add in all to that, then it is called ethanol. Ethanol. Like that, how you get the name. And we have rules for naming of um, alcohol, and we will study them later under the alcohol lesson. So the name, we are adding suffix to the parent chain, or we call that the this group, we call that the root name. We add all to the root name as a suffix, then it is that. Ethanol, methanol, propanol, butanol, heptanol, like that. Then as substituent group, we use that hydroxy. No need to know these things because we are going to study in detail later. Then these kind of compounds are known as ketone. Ketones are named by adding the suffix on to that. Say you have a ketone. The simplest ketone contains 3 carbon. Because to be a ketone, there must be carbon atoms attached to the carbon having this oxygen attached. Because of having 3 carbon atoms, it is prop. So we get the name as propanone later. And these are called the aldehyde. The name of the aldehyde ends with the L, alcohol, all, aldehyde, L. There's a difference. All and L. Aldehyde. Ethanol, methanol, propanol, butanol, and so on. And the cyanide groups. As a functional group, you may have cyanide. Then the compounds are known as nitrile compounds. And substituent group, we use cyano. And these are called the amides. The name means with amide, methanamide, propanamide, butanamide, pentanamide, hexanamide, and so on. We get the name. And these are called the esters. In the naming of esters, we have special rules and special method. So I can't say, I can say something like this: methyl ethanoate, ethyl methanoate, like that. Right? The name become O8, O8, O8. The name ends with O8. Ethyl ethanoate, methyl ethanoate, propyl propanoate, like that. Then they will not become as substituent groups. And the carboxylic acid, you know that acetic is a basic carboxylic acid. Then the name ends with oic acid. Acidic now we have 2 carbons, CH3, COOH. This is a carboxylic acid having 2 carbon. Having 2 carbon now, eth. And the name must end with oic acid. So the name will be ethanoic. Why? Name has to be ended with oic acid like this. You can see oic acid. So having 2 carbon, we get the ethane name and remove that E and add oic acid. That is the rule. Then it is ethanoic acid. That's how you get the name of that ethanoic. That is called simple acid. The acetic vinegar. We are using atom vinegar. Vinegar consists of the ethanoic acid. Ethanoic means acetic acid, right? That is the commercial name, acetic. Then the IUPAC nomenclature. Nomenclature means naming of compounds. how you can name the organic compounds. I told you that we have millions of organic compounds. Then how you can remember the millions of compounds, millions of names of compounds. That's why we have a systematic naming system. In this case, no need to remember all the millions of compounds. Instead of that, you need to remember few number of rules, maybe less than 10 rules. By remembering less than 10 rules, you can name millions of compounds. See how nice it is. So we just follow the names. Naming, in the naming, we just follow those rules. For different compounds, we may have different sets of rules in naming of those compounds. Let's see. The nomenclature is the technical term for naming. In chemistry, we use the nomenclature to say the naming. Writing names we call the nomenclature. Nomenclature means naming. එතකොට මෙතන කියනවා in order to name organic compounds, you must first memorize few basic names. Basically, you need to know how to get the name depending on the number of carbon. If it is 1eth as meth, if it is 2eth, 3 prop, and so on. These names are listed within the discussion of naming alkanes. In general, the base part of the name reflect the number of carbon in what you have assigned to the parent chain. If you have only one carbon, then we call meth. That is, depending on the number of carbon, you get the name. Name assigned to the parent chain. Parent chain is the chain having the longest number of carbon atoms. First, we choose the longest chain, call that the parent chain or the main chain. Then, suffix of the name reflect the type of the functional group. If it is an alkane, we add ane. If it is alkene, we added ene. If it is alkyne, we added ine. Then we know that whether it contains a functional group or not, and also what the functional group is. Ene වලින් නම ඉවර වෙනවා නම්, if the name ends with ene, then it is a compound like this, having double bond. We call that we name them as alkene. Alkane, alkene, alkyne, and so on. In general, in order to name the organic compounds, you must first memorize a few basic names. These names are listed within the discussion of the naming alkene. In general, the base part of the name reflects the number of carbon atoms, carbon in the particular compound as its parent chain. Right? Number of carbon present in the parent chain will reflect the name. And the suffix of the name reflects the type of the functional group present on the parent chain. Other groups which are attached to the parent chain are called substituents. All the others are known as substituents. Say you have a chain having 4 carbons as the longest chain, and you may have another carbon atom like this, say CH. CH 3, CH3, CH2. මේක මොකද්ද වෙන්නේ? CH3, CH2, CH, CH3. එතකොට first we need to find the longest carbon chain called as the parent chain. In this case, you can label the longest carbon chain. We first find the longest carbon chain and then label them. Therefore, you can put 1, 2, 3, 4, or 1, 2, 3, and 4. Or you can name it from starting from this carbon 1, 2, 3, 4. See, there are several ways of numbering that, but that is not good, right? If someone choose this longest carbon chain having 4 carbon, he will get a name. And if someone use this, he will get another name. And if someone use this chain, this as the longest chain, then the name will be another one. That means for the same compound, you will get different names. For the same compound, you will get different names. Therefore, what we do, we have to have a proper method of numbering the chain. First, we choose the longest chain and then number the chain. First, we get the longest chain and then number the chain. How you can do it. The name given to a compound according to the IUPAC nomenclature typically has 4 parts, like this: prefix, locon, parent, and the suffix. Prefix indicates all the substituent groups. See, where and what are the substituents? Where and what are the substituents? To which carbon the substituent is attached. That is where. And what means, what is the substituent group? Say, you have 5 carbons like this, 1, 2, 3, 4, 5 carbon, and you may have chlorine here, bromine here, and CH3 groups here. And CH3, here you can put only 1 hydrogen, and here you can put another hydrogen and CH3 group here. Then suffix means the where and what substituents are attached. Where කොහෙටද මොනවද? See, you have this chlorine, CH3, bromine as the substituent. We don't get hydrogen as substituents. Other than hydrogen, all the other groups attached to a certain carbon atom are known as substituents. Then in naming this, these are the substituents. And where means to which carbon it is attached. Then you can number the chain as 1, 2, 3, 4, and 5. Then you can say in second carbon you have chloro, CHLO, RO, chloro. And on third carbon you have bromo. Where means to which carbon it is attached. What means what is the substituent group, like bromo, chloro, and so on. And the CH3 is having 1 carbon and it is alkyl group, so it is methyl. Then you have methyl group on 4th carbon. Now we have where and what. that come. Then the location has to be given. Where is the primary functional group is in. If there is a functional group, then on which carbon you have that functional group. Say you have 4 carbons, then the OH group is if the OH group is the functional group, then that may be on the first carbon, and sometimes it may be on the second carbon, and so on. Then we say the locant means the location of the primary functional group, to which carbon that functional group is attached. Then the parent. Parent reflect the number of carbon atoms. මෙයාගේ name එක ලියනවා නම් we write it as a but. Why? This contains 4 carbon. If you write down the name of this particular compound, then we call it is pent. Why? It contains 5 carbon atoms. That is the parent. And the suffix. Suffix is the name of the indication of the primary functional group. If it is an alcohol, we name the end with all. If it contains a 4 carbon, it is butanol. If the OH group attached to first carbon, then we say 1-butanol. If it is attached to first carbon, then we call 1-butanol. That means we have an organic compound having 4 carbon, and the functional group is all. That means an alcohol, and that alcohol part is attached to the first carbon in the chain. That's how you get the name. That's how you get that name. Right? Then those are the basic rules or basic things you need to know in naming of compounds. Now we are going in detail how to write down the names of alkane. How to write down the names of alkane. First, you need to select the longest carbon chain. That is called the parent chain, which has the highest number of carbon atoms. Select the longest chain, which has the highest number of carbon atoms. That's why I choose this chain having 5 carbon. Then second one, name the parent chain starting from one end to the other end, numbering that. You have to number it, giving number 1, 2, 3, 4, 5 up to the last carbon atom. So you choose the parent chain and label the carbon atoms. 1, 2, 3, 4 like that. Next, name of the alkane ends with the "ane" suffix "ane" added to the stem name. Stem name is the name of the parent chain or the name obtained according to the number of carbon atoms. If it is 1 methane, methane, methane. If it is 5, pent, ane, pentane. And fourth rule is place a hyphen between name and a number. Place a comma between 2 numbers. I used this hyphen to separate name and number. Name and number. And name and number like that. Then we can write down the name of the simplest hydrocarbon, CH4. That is, it contains only 1 carbon and it is an alkane. So you get the parent chain as the longest chain. It contains only 1 carbon. So it is obviously 1. Then no any other functional group, that is ane, So one carbon is met and you add ane to that. So the name is methane. If you have two carbon, the name is CH3 and CH3. The name will be ethane, ethane, ethane. In this case, you choose the longest chain that is having two carbon and no substituents. Then no need to number it. If you have substituent, then only you name the or label or the number the chain to choose the longest. Then if you have CH3, CH2, CH3, then it is propane by having three carbon and N. Then next one is CH3, CH2, CH2 and CH3. Then it is called butane, no substituents. Only the parent chain. Parent chain consists of four carbon. So having four is butane, butane. If you get something like this CH3, CH, CH2 and CH3, oh no, CH3 say here. And here another CH3. Then you choose the longest carbon chain, that may be this. And then you have to label that longest carbon chain. First you get the longest carbon chain and label it as 1, 2, 3, and so on. Then on the second carbon, though you number that from left side to right side, you will get number 2 to the central atom or center carbon, and it has this substituent. Then the substituent is on second carbon. Then how you can write down the name? First, you need to identify where and what and where it is attached. See, according to this summary, the prefix, where and what are the substituent? Where is on second carbon, 2, and what is the substituent? Methyl. Then 2-methyl. 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 And then the parent chain consists of 3 carbon. So it is prop. And the compound is alkane, U and ane. Then 2-methyl propane. The name is 2-methyl propane. There is methyl propane then. Next one, when the substituents are present, number the main chain starting from the end nearest to the substituent group. Again, if you have CH3, CH2, CH and CH3, and here if you have bromine, then you can choose the longest chain as or chain having 4 carbons, see 1, 2, 3, 4, and you can number the chain giving number 1, 2, 3, 4, or you can number the chain from this end, then it will be 1, 2, 3, and 4. Then when we number the chain, we have to number the chain from the side where this substituent carbon gets the least number. In this case, if you number from left side, it will be 1, 2, 3. Then on the third carbon, you have bromine. But if you get that in the other way around, then carbon number 1, 2, 3, 4. Then this Br group is attached to the second carbon. This Br is attached to the second carbon. So best name now will be the 2-bromo. 2-bromo. We choose the longest chain and identify the substituents, and you give the least number to the carbon having substituent group. Then it will be 2-bromo. Why? 1, 2, 3, 4, 2-bromo. Then you have 4 carbon and it is N. 2-bromo but 2-bromo but N. Then it is 2-bromobutane. The name is 2-bromobutane. Then write down the name of this compound, CH3CH2C, CH3, and Br here, and another CH3. Write the name. Is this okay, Puta? Can understand? Okay, good. Then write down the name of this compound then. This one. And write the name here. Send me message as a message, this name. Send me the name as a text message in this chat box. Choose the longest chain and number the chain giving the smallest possible number to the substituent carbon. Yes. One says 2-bromo, 2-methyl-butane. I will copy that name and paste it here. Here, no? Yes. that's okay. Maybe okay with some corrections or not. This is the name you have given me. Make it the you can label the longest chain. Right? Number the longest chain. When you number the chain, you can use 1, 2, 3, 4. Then put the third carbon with the carbon which consists of this substituent. But if you starting from this side, 1, 2, 3, 4. Yes, that is the best way of numbering. That means from right to left is the way of numbering. What this is. Then you have bromo and CH3. When we write down the names of when more than one substituent group present, number the main chain starting from the end nearest to the substituent group. And the other thing is, okay, when we name the substituent, we have to name them in the alphabetical order regardless of the number of the carbon. එතකොට මේ name එක හරි. 2-bromo 2-methyl butane. Here you have left space that is wrong. And the other thing is in between any two name and number, you have to put a hyphen. You have to put a hyphen. And then the name will be, now you have to remove this space also. Then this is the name. 2-bromo 2-methyl butane. That is correct. This name is correct now. 2-bromo. Why? In between name and number, you have to put a hyphen. In between name and number, put a hyphen. When substituents are present, number the main chain starting from the end nearest to the substituent group. So 2-bromo 2-methyl butane. Next one, when more than one substituent groups are present, number the main chain starting from the end nearest to the substituent. When more than one substituent groups are present, number the main chain starting from the end nearest to the substituent group. Again, if you have CH3, CH2, when more than one substituent groups are present, number the main chain starting from the end nearest to the substituent, which is named first window. And something missing here, neither. Yes, you have to write something like this. Make a the substituent group. When substituent are present, number the main chain is starting from the end nearest to the substituent groups. But when we have more than one substituent groups, number the main chain is starting from the end nearest to the substituent, which is named first. Which is named first. Substituent nearest to the from the end nearest to the substituent, which is named first substituent group, which is named first substituent group, which is named first, which is named first. And substituent groups are named in the alphabetical order of the first letter of the name. Substituent are named substituents are named in the alphabetical order of the alphabetical order first letter of the name. Like that. When more than one substituent groups are present, number the main chain starting from the n nearest to the substituent group which is named first. And substituent groups are named in the alphabetical order of the first letter of the name. If it is bromo and chloro, we write down bromo first and then the chloro. Why? B comes first. B comes first. Okay. Then you may write down the name of this compound. CH3, CHCl, CH, CH3, CHBr, CH3. Write the name of this compound now. And send me the name. Yes. Let's see the name now. This is the name given by Yasindu. Yasindu. Let's see whether it is correct. First, we name the chain starting from this side 1, 2, 3, 4, and 5. Then we have many substituents. Then you give priority to the substituent which is named first. Mono the substituents. This is chloro, CHLORO. This is bromo, BROMO. This is methyl, METHYL. What is the substituent you name first is bromo. Why? That is the first according to the alphabetical order. Then, therefore, you have to name the chain from the left to right, never the right to left. Then 1, 2, 3, 4, and 5. Now, bromo gets 2. Then 2 bromo is correct. Then you have chloro and methyl. Then according to the alphabetical order, you have to name chloro first. Then for chloro, it is correct. Then you have methyl group on the third carbon. So 3 methyl also correct. And then pentane. Why? On the first, the parent chain, on the longest chain, you have only 5 carbons. So it is methyl pentane. So this name is correct. How about the Sasruta? Is it correct in yours? Yes. Good. And then when more than one of a given substituent are present, then we use prefix di, tri, tetra, and so on to indicate the number of occurrence. Like this way, if you have CH3CH, Br, and CHBr, and CH2 and CH3. Then you have 2 bromo, then it is di. Dekak තියෙනවා di. And you label the parent chain giving 1, 2, 3, 4, 5 from this side, or you can use in the other side giving 1, 2, 3, 4, and 5. If you label from left to right, as in red color, the substituents are get 3 and 4. But if you label in the other way around, then it is 2 and 3. So 2 and 3 is better than 3 and 4 because the smallest numbers are given if you number the chain from left to right. Then the name will be 1, 2, 3, 4, 5. So name will be, now it says that Uda, if you have 2 numbers, then we put a comma to separate them. Put a comma to separate the numbers. Place hyphen between name and number and place comma between 2 numbers. Now you have bromo twice. එතකොට අපි ලියන්නේ 2, 3 hyphen 2, 3. Why? On 2 and 3 you have bromo. 2, 3. As you have 2 bromo, you say dibromo. As you have 2 bromine, it is di. 2, 3 dibromo. And now you don't have more substituents. And the longest chain contains 5 carbon, therefore it is pent. And it is an alkane, so I put that in. 2, 3 dibromopentane. 2, 3 dibromopentane is the name. Then the other thing is substituents are listed in the alphabetical order irrespective of their position in the carbon chain. To alphabetize this, ignore the numerical ditrittetra. මේ ditrittetra දාලා තියෙන්නේ not to the substituents. That is for to indicate the number of occurrences. Therefore, we don't use that ditrittetra as the when we consider this alphabetical order. Right? Bromo. Bromo nam B, not D. Dibromo, the starting letter is B, not D. Dititetra will not be considered. And ethyl would come before the dimethyl. Why? Dimethyl now, the name start from that M, methyl. Di is to indicate the number of occurrences, how many times you have, how many such groups are available. And but don't ignore the positional prefix such as iso and t. ඒ වගේ අපි ගන්නෙ නෑ in our naming system. Put the substituent in alphabetical order in naming those compounds. So now you can write the names of these compounds. Say you have CH3, CCH3, and here CH3, sorry, CH2, CH3, and then CHBr, CH3. Write down the name of this, and you can write another name like this, CH3, Br and Br, then CH3, H and CH2 and CH3. Write down the names of these two compounds. Oh, sorry. In this case, Buddha, you can choose 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. That means dark blue or light blue. Then bromine must get the least number. Bromine must get the least number. You have to label the chain as in the dark blue color. As in the dark blue color. Not the light blue. Light blue now, bromine get number 4, dark blue, bromine get number 2. And the longest carbon contains 5 carbon. You are not ending with this carbon, right? That is a substituent. Then you have two substituents as CH3 and CH3 on third carbon. And one bromine. Therefore, the name must be like this. The name must be 1, 2, 3, 4, 5, then 2 bromo, 2 bromo, 3, 3 dimethyl, 3, 3 dimethyl, and then pentane. Pentane. And in this case, the longest carbon chain will be 1, 2, 3, 4, and 5. Then you will get number 2 to the bromine. So 2 to dibromo. That's correct. Then 3-methyl pentane. Correct. This name is correct. The name given by Yasiru, I think. Yes. Then if substituent gain the same number on both sides, then you will give priority to the side which you are going to name first. And if you have CH3C, CLH and CHBr and CH3, then you can number the chain 1, 2, 3, 4. Then the substituent will get 2 and 3. If you number that from 1, 2, 3, 4, again you will get number 2 and 3, the same numbers. Then you will give priority to the bromine. Why? That is the one which you are going to name first. එතකොට අපි කියනවා එයාට you have to label the chain starting from right to left. Then 2 bromo, 3 chloro, like that. Then write down the name. Yes, in this case, the name will be 2 bromo, 3 chloro, butane. Correct. Okay. These are the basically I needed to cover today, and also I came up to that on time. And you know how to name the alkane. Now you know how to name the alkane. And please go through the notes several times and write the names of them. And I will send you some compounds as a PDF to name them. You will receive that probably tomorrow. You will get it and then you will try naming of them. Right? And if you need anything else other than these things, let me know. Then I will try my level best to give you the best. And hope that this is clear. And some said that they are falling on sleep and signal problems and so many reasons. But reasons may not be give marks in your exam. So please, I wish if you join live, and I'm not going to give you any videos or any recordings, because if we give recordings, then you will